Here's one way to find the rational zeros of a function. This usually works with equations of order 3 or more, but there are other techniques. Alright, so we'll try this. So first thing we got to do is we got to find all the p's. The p's are the constant, which would be here. In this case, it would be -10, and all the factors of -10. And you should also do the positives and negatives, right? Because you can do -10 times 1, you could do +10 times -1, and so on. So that's all the p's. Plus and minus 10, plus and minus 5, plus and minus 2, plus and minus 1. Okay, so we found all the p's. Next step is we got to find all the q's. So the q's consist of the coefficient of the leading term, but remember, you have to have your equation in descending order of exponents. So I already have it in descending order of exponents, right? Because this is to the third power, to the first power, to the 0 power. Alright, so we want to get the coefficient of this guy, which is 2, and then all of its factors. Well, that's just plus and minus 2, plus and minus 1, right? So we're just doing whole numbers right here, right? Okay, so far so good. Then what we got to do is we got to find all the combinations of the p's divided by the q's. Okay, so this could take a while, but a lot of them are going to overlap. Okay, so notice, let's start with the 10. We do 10 divided by 2, but that's 5, right? So the p over q, that's 5. So I didn't write it down here. Right? 10 divided by 1 is 10. No use doing that. So I did the 5 over 2. Okay, that's new. I don't have the 5 over 2 in the p's or the q's. So I have it here. So 5 over 2, and then you do plus or minus. And 5 over 1 is 5, so there's no use writing that down here again. Okay, so now I'm going to do the 2's. Well, 2 over 2, that's 1. I already have 1 in both of these. Right? And 2 over 1 is 2. I already have that. So here we go. So 1 over 2. Oh, I don't have that yet. So these are the only new p over q's here. The only new values. Right? All the other values are duplicates. I already have 2. Probably didn't have to write 2 twice, but I did it to show you the difference between p's and q's and the 1's. Alright, so these are all the things we're going to have to test. Okay, so now here comes the slightly tedious part. What we need to do is we need to substitute all of those values we got. So all these values we found here, what we're going to do is we're going to plug them into the original equation. And when you plug it in or substitute them and you get equal to 0, that means you found a rational zero or a solution. Okay, so here's what we're going to do. I did this kind of fast, sorry. So here we go. So if I substitute 10, I get something that's not equal to 0. Right? 2,000 minus 30, that's going to be what? 1,970 minus 10, 1,980, not even close to 0. So that 10, not a solution. Substitute -10, same thing, very far from 0. So I kept substituting, right? This takes a little while. Right? Oh, finally got one. When you substitute in 2, right, you get 16 minus 6 is 10. 10 minus 10 is 0. That means 2 is a solution. Right? It's a rational 0 for us here. Here we go. Then we just keep going down the line. So I got -2, and did 1. 1 doesn't work. -1 doesn't work. Oh man. 5 over 2, that's a yucky fraction. -5 over 2, yucky fractions. 1/2. 1/2 is close, but not really. But -1/2, nope, that doesn't work either. So the only one out of all of these was 2. So that's the only rational 0. So if you were to graph this function, it should only cross the x-axis where x equals 2. Excuse me. All right. So let's try one more to see if you understand. So same thing, right? I'm going to find all the p's. Okay. All right. The p's, I remember, are the constant. So the p's, we got to do that, and we got to find all the factors. Wow, that's a lot because it's 12. All right. So there we go. And remember the plus or minus. Okay, found all the p's. Got to find all the combinations of the q's. That's not too bad. It's just a 2. Alright, notice these overlap. so that's not too bad. Now we gotta find all the p's over q's. Okay. Remember, a lot of these overlap. 12 divided by 2 is 6. Okay, plus or minus 6 or what? I already got it here. 12 divided by 1 plus or minus 12. Already got it. 6 over 2 is 3. Oh, already got it over here. No use writing it down here. 6 over 1 is 6. 4 over 2 is 2. Already got it here. 4 over 1 is 4. Already got it. 3 over 2. Don't got it. That's why I add it right here. 3 over 1 is 3. Already have it. 2 over 2. I already got it. 2 over 1. Already got it. 1 over 2. Aha. There we go. So don't forget the plus or minus on both. So these are all the values we got to try now. Same thing. You just got to do it one at a time. By hand it takes a while. But through the magic of computers, there we go. So I calculated these for you, right? So here we go. I substitute in 12 right here. I get some crazy big answer, not even close to 0. Negative 12. A little closer, but nope. 6. Nope, super big. Negative 6, close, but not quite. 4. Nope, too big. Negative 4. Oh, that's pretty close, but nope. 3. Nope. Negative 3. Aha! Negative 3 equals 0. So negative 3 is a rational 0. That's a solution. Let's try 2. Nope. Negative 2. Negative 2 checks out too. Pretty good. Let's try out this one. So you have to be diligent and you can't be lazy. You got to try every possible P, Q, and P over Q. Alright, so here we go. I tried this one. Here we go. This one doesn't work. Doesn't work, doesn't work, doesn't work. Alright, so I tried every possibility, positive and negative. So we got one there, right? So negative 3, negative 2, and negative 1. So if you were to graph this function on a graphing calculator or some type of program, the graph would cross the x-axis at x equals negative 3, x equals negative 2, x equals negative 1. Alright, so that was one way to find the rational zeros. There are other ways. Alright, that completes our problem.